All right. What we're going to take a look at here are dealing with parallel and perpendicular lines. Now, we know what parallel lines look like. They have the same slope. They're moving the same direction. No big deal. Perpendicular lines, however, have a little bit different rule. Perpendicular lines are always going to be the opposite reciprocal. Okay? So, that means that, for example, opposite of 1/2 is going to be -2. Opposite of -6 is going to be 1/6. So what I want you to do is make sure that you get this information into your little book. I'll give you a few moments here. Make sure that you get that in there. All right. Let's take a look at how this stuff is going to be used. Now, I want to find the slope of line A. As you remember, hopefully, slope is always going to be the rise. Goes up positive, down is negative, and the run is always moving to the right. This is always how we want to look at things. How does the graph move from left to right? So I see that it's going up, so that I know it's going to be positive. So it's going up how far? 1, 2, 3, and over 1. So it has a rise over run, 3 over 1, which simplifies down to just simply 3. Okay? So the slope of the A is going to be 3. Now, what would the slope of a line parallel to A be? That would also be 3. Parallel, it's going to have the same slope. Now, if it's perpendicular, it is going to be opposite reciprocal. So, this is positive. So that means that it is going to have to be what as negative? Yes, sir. Yes, it is. So it would be negative, and then it's going to be what's the fraction? 1/3. That's it. That was positive. This will be negative. 3 over 1, 1 over 3. Now, we need to be able to identify parallel and perpendicular lines. What we want to do is make sure the equation is in the following form. Y is equal to mx plus b, slope-intercept form. If we have it in that form, we know exactly what the slope is. The slope is going to be m. So, if I look at this one is in the correct form. That means the slope here is 2. This one is sort of kind of there. It just needs to be rewritten a little bit. So y would be equal to 2x minus 3. So the slope is there. And they are the same. So that means that they have to be what? Parallel. Now, are these lines parallel or perpendicular? Or neither? Well, here the slope is 2 over 3. Here the slope is 3 over 2. So does that mean they're perpendicular? What's missing? It's negative. So that means that they are going to be neither. Because I get 2 over 3, 3 over 2, it is not the opposite reciprocal. Now, I'm going to give you a few moments here, and I want you to make sure that you have this one down here. Point slope form. Important to have. All right. So, what we need is, we need this for when we want to graph a line given an equation and a point. Now, we know that this here is in slope-intercept form. What's its slope, by the way? 1. So we know that that's going to be 1. So, given that y minus y1 is equal to m times x minus x1. Now we're just simply going to fill in the blanks. Now this point over here, x1, comma y1. You've seen this before, but That's where we're going to get our x1 and our y1 for those of you paying attention, following along, and pretending you're interested. So, y minus, what's y1? That's 8, so we'll put in the 8. What's the slope? We wanted parallel, so that's going to be 1. X minus 3. This is where they come from. The nice thing about this is if we have these type of things, we're just plugging them in. We know what goes where. So now we just do the algebra on it, so we end up with y minus 8 is equal to x minus 3, add 8, and I get y is equal to x plus 5. So, what we wanted to do is identify a line that was going to be parallel to this and go through 0.38. So I'm going to go and graph out this first. Y is equal to 1x plus 2. That means y-intercept is at 2. Slope is 1 over 1, right? Up 1 over 1. So I can do all that. Back it up if I so choose. Make sure I stay in the right spots. Make myself a line. Said. Okay. So I've got my parallel line there. Now, the next thing is I wanted another parallel line that was supposed to go through at x plus 5. Okay, it's got the same slope. That's easy enough. So, let's see. So I've got my other line here. Y-intercept was at 5, so that I know that I am going to have to move this thing 1, 2, 3, 4, 5. So that would be the next one. Now the question is, did it actually go through 3, 8? That's what I wanted in the beginning, right? So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Went right through it. Okay. So that's how you get the equation of a line to pass through a point. Let's try this one. Oops. He's still there. So, move those off to the side yet. Oh, wrong way. So, want to graph the line that is perpendicular to that. Passes through the point 2, 4. So we're going to go through the exact same process again. We need the slope. Well, the slope here is 2 over 3, so what is going to be the opposite slope? For the 3 over 2 reciprocal, but it's got to be opposite, so it would be negative 3. So, y minus what? Y minus 4? Okay. Whatever goes with y will be the y here. They go together. So it's going to be negative 3 over 2, x minus 2. So I've got y minus 4 is equal to distributive property. Those two get multiplied together. Negative 3 over 2, x. These get multiplied together. So that'll be negative 3 over 2 multiplied by negative 2. 2's cancel out, plus plus. So I've got y minus 4, negative 3 over 2x, plus 3, add 4, add 4. So it looks like my equation is going to be y is equal to negative 3 over 2x plus 7. So, first equation it said was y is equal to 2 over 3x. Where's it going through the y-axis? Where does it say 1? There's nothing back here. So if there's nothing back there, what number am I going to add to it to give me nothing? That's why we always want to do is y is equal to negative 3 over 2x plus. What number can I add back there that means nothing? 0. So I know that it has to go through the point here at 0. So I'm going to grab this line down here. If I put that over in here, I'm going to have to check this, make sure the slope is actually working. So slope is, oops, I put the wrong thing there, didn't I? That was my bad. Sorry. So, up 2, 1, 2 over 3, 1, 2, 3, point. Up 2 over 3, 1, 2, 3. So it's hitting the points, right? It's doing what we expected it to do. Now the other one said it's supposed to go through at 7. So we got 1, 2, 3, 4, 5, 6, 7. And hopefully this line is still set at the correct slope, but we're going to have to check. So that was down 3, 1, 2, 3 over 2, 1, 2. Down 3, 1, 2, 3 over 2, 1, 2. So it's set. But my last question is, did it go through 2, 4? 1, 2, 1, 2, 3, 4. And it went right on through. This is the work that you need to do to identify what these equations are. So when I want you to go through and find the line, you need to go through and find the equation of the line. So here's a question for you. In a race, one swimmer is swimming at a rate of 21 meters per second. Another swimmer gets a 5-meter head start and is also swimming at 21 meters per second. What is the equation that will model the distance y that each swimmer has gone after x seconds? Will the first swimmer ever catch the second? So will the first swimmer actually ever catch a second? Why? So, that's the catch. They're going the same. So they have the same slope or the same rate. So if I take a look at number 1 here, he's got at a rate of 21 meters per second. So y is going to just simply be equal to 21x. That's all it is. Every 21, for every second he goes 21 meters. So now, the next one. Y is equal to 21x, but how much more does he have? Plus 5. Okay. So because they're going the same rate, because the slopes are the same, that's what's going to happen. So I'm going to give you a minute or so here, and I want you to do this problem. All right. So we're supposed to find the slopes out of lines that are parallel and perpendicular to V. So let's start it off this way. Leah, what do we got for parallel? What would the slope be? What? Did you work out the slope? Why? You're working on it, huh? So, if I take a look at this, it has to go up 1, 2 to go over. So the rise is 2, and the run is 1, 2, 3, 4, 5, correct? So that would be 2 over 5. So, let's see, Gavin, what would be the perpendicular? Opposite reciprocal. Well, what's the reciprocal of what you see there? 5 over 2. What's the opposite? Negative. Okay. Give you a minute or so, let you think about these. Alright, so Hayden, what do you think? Neither, he says. Let's check. Are they in the form y is equal to mx plus b? Because that's really the only way that we've got to tell right now. So the first one I look at, and it's y is equal to 3x minus 2. That's fine. The other one is 3y plus x is equal to 6. Well, I got to put it in this form. So I subtract x. So now I have 3y is equal to negative x plus 6. Divide by 3. So y is equal to negative x over 3 plus 6 over 3. And when I simplify this, I get y is equal to negative 1/3 x plus 2. So if I take a look at this, the slope here is going to be 3 over 1. The slope that's over here is negative 1/3. So in reality, they are what to each other? Perpendicular. Now, you have to do this much work in order to figure it out. You have to go through that process. This is the work that I expect to see on your assignments. So, I'm going to give you another one here. Give this a try and see what you come up with. All right. So, let's go. What do you think? Parallel, perpendicular, in either. Perpendicular, he says. Let's check it out. The first equation is 4y is equal to 2x plus 3. That's not the form we need. So we need to divide both sides by 4. Y is going to be equal to 2x over 4 plus 3 over 4. Y, that simplifies down to 1/2 x plus 3/4. The next one, we have y plus 2x is equal to 9. Looks like I need to subtract 2x to both sides. So I have y is equal to negative 2x plus 9. So this one here is negative 2 over 1. This one here is 1 over 2. So they are perpendicular to each other. They are opposite. Good. So, give you a little time here and ponder this one. So, Keely, did you come up with an equation? Hmm? Oh, just read me what you got. That's okay, so you have y is equal to negative 2x, and that's it? Well, you wouldn't want plus 7. You just want that. Because it's going through the origin, and the origin are coordinates 0, 0. So the y-intercept is 0. It's not going through the y-axis any other place. So that's it. Y is equal to negative 2x. I know, it's kind of a sneaky one, right? So, all right, I'm going to give you a little time. Play with this one. So, Caleb, you got an equation for it? Like that? All righty, let's see if this is actually going to work out? So we want perpendicular, so we got a slope of negative 4/3, so 3/4. We got the right slope, so it's going to be y minus 3 is equal to 3/4 x minus 2. So I got y minus 3 is equal to distributive property here, 3/4 x minus distributive property here, 3/4 multiplied by 2. So it looks as though I gotta cancel here, so that'll be 2. So I'll have y minus 3 is equal to 3/4 x minus 3/2. So far, so good? Need to add 3 to this side, add 3 over here. Problem is adding 3 to this, it's negative. Whenever you're working with fractions, choose the improper fraction denominator. So 2, 3 times 2 is 6. So negative 3/2 plus 6/2 is going to give me 3/2. So it looks like that would be my equation. Or did you say 3/2 and I missed it? What? Yeah, but this here is negative. This is positive, so it'd have to be to go to 3. So, there we go. So, one more. Give you a little time to think about this one. So, it's kind of... Will the first rower ever catch up, or will the second rower ever catch up to the first? Did you read it? So, 2 rowers are canoeing parallel to one another in a stream. First rower is traveling at a rate of 2 meters per second. The second rower is traveling at a rate of 21 or 2.1 meters per second. And the first rower is 4 meters ahead. So, first and foremost, are they going the same speed? So will the one that's going faster eventually get ahead of the other person? They would have to be, right? So that's the first thing we got to look at, is we got to identify these rates. So if I had number 1 and number 2, y would be equal to, in this case, it's going to be 2x. Y here is going to be equal to 2.1x. So one is going faster than the other. So eventually, somebody is going to. So that would have to be a yes for that one. Now, I got to write the equations. The second one, it says the first rower is 4 meters ahead of the second one. So he's got an extra 4 to go with, right? Now, this is where we would go and graph things out to see where they would meet. We know that number 2 is going to eventually go further than number 1. Has to. Why? Because he's going faster. So, what I'm going to do, though, is I'm going to use the graphing calculator to help us out with this. So let's check here. 7.2, reset. Yep. So, first equation I'm going to put in is 2x plus 4. Next one is 2.1x. So if I graph them out, this is what I see. Now your normal graphs that you get, do it on a 10 by 10 grid, this is what you're going to end up seeing. It's not really going to do much of anything for you. Okay? You have to make sure that you put this in the context of what's going on. So, window. Do we care what negative is? No, because, and x here is this time, we don't care what happened 10 seconds ago. So we'll start at 0. And we've already seen that we got to go more seconds, so I'm going to go up to 25, maybe 25 seconds he'll pass. Negative 10 here means, well, that's 10 back someplace else, right? So we're going to start with 0 there. And Y max is how far they're rowing, and I'm going to move that up to 50 and see what we come up with, because they are going pretty good clip. So I graph it. There's the first line. There's the second line. So is the second one getting closer? But I'm going to have some more. So I'm going to move this, say, out to 50. And I am going to move this up to, say, 100. And graph. Okay. So there's the first line again. There's the second line. Looks like they hit someplace, right? Now, one of the nice things about the graphing calculator is it has the ability to go and tell you where they intersect. So I'm going to hit second. This is I'm going to go down to number 5. And it tells me that after 40 seconds, they are going to be in the same place at 81 or 84 meters. So they will meet. After 40 seconds, then the other one will be a hit. So a lot of these things, look at it, read it. What is the situation talking about? You do not necessarily have to understand creating the equations to answer the question. Will the second rower catch up to the first? Yes. Why? Because the second rower is going faster. So keep these things in mind, and you've seen the work that is necessary to answer them. So I'll let you guys get to work.